Hey there, everybody. So today's lesson is going to be a little bit on negative exponents, and then I'm going to try to run through just a few problems where you're going to use exponent rules, and I'm going to want to show you how you can express your answers with no negative exponents. I know that's something that's been asked of you in CPM on occasion, and some people have expressed like they have some trouble with that. They'd like a quick review of it. So here goes. All right. I'll expect you to take a few notes on this video, and then I actually want you to do a quiz that I loaded onto Google Classroom. I'll explain that at the end of the video. Okay, so the first thing I'd like to do is just look for some patterns here in this table, and you can see on the left-hand side of the table, I've posted some numbers in exponential notation, and what I'm going to do as I'm speaking is I'm actually going to put the value of each as we're going along. You can see I already have 2 to the 4th as 16. So 2 to the 4th, of course, is 2 times 2 times 2 times 2. I think of that as 4 times 4, right, 16. So 2 cubed is 8. 2 to the second power, or 2 squared, is 4. And 2 to the first power, of course, is just itself. Before I go any further, I just want to look real quickly at the pattern. You can see as you're going down the table, you're dividing by 2 each time. As you go up the table, you're multiplying by 2 each time. And if you think about that, that makes sense because this is just 2. This is 2 times 2. Well, this is 2 times 2 times another 2. So, oh yeah, that makes sense. You'll double it every time you go up. We're going to keep going down though, and the pattern is going to continue, right? Every time you decrease the exponent by 1, if the base number is 2, you're going to divide by 2, which, by the way, would be the same as multiplying by 1/2. All right, so anyway, 2 divided by 2 is 1. Note 2 to the 0 power is 1. You may have heard it said that anything to the 0 power is 1, and that is true. We'll talk a little bit later about why that's the case, but I just want you to notice it showed up here. 2 to the negative 1 power is 1/2. 2 to the negative 2 power is 1/4. All right, what I'm doing is I'm cutting them in half each time. Right, half of 1 is 1/2. Half of 1/2 is 1/4. Oh, what's half of 1/4? 1/8. Right, and you can also think about it as you're multiplying by 1/2 each time. Right, what's half of 1/8? Well, 1/16. Okay, so you can see this, I purposefully highlighted. All right, so the other pattern that you see, besides this being cut in half each time we go down 1, so you can see, well, 2 to the 4th is 16. 2 to the negative 4th is 1/16. So it's really the same as 1/2 to the 4th. Oh, yeah. All right, that's true here, too. All right, 2 to the 3rd is 8. 2 to the negative 3rd power is 1/8. So if you look at this, you can see, well, if you're trying to figure out a number to the negative exponent, you can just find the one that's positive, drop it to the denominator, make the numerator 1, right? So 2 to the negative 2 power is the same as 1/2 squared. 2 to the negative 3rd power is the same as 1/2 2/3. So the other thing you can do is you can say, well, just make the exponent positive, drop it to the denominator, and that would work. Just make sure your numerator's 1. All right, so let's take a look at the 3's. Let's just see if the same thing holds true here. So 3 to the 4th power, I think about that as 9 times 9, that's 81. 3 cubed, so that's going to be 9 times 3, that's going to be 27. 3 squared is 9. 3 to the first power is 3. You can see each time you're going down, you're dividing by 3. Again, should make sense if you think about it. So 3 divided by 3 is 1. Oh yeah, look at that. 3 to the 0 power, 1. Well, that's because we just did 3 divided by 3. Remember in the table where our base number was 2, it ended up being 2 divided by 2 to get that. All right, I'll come back to that in just a minute. But remember, we're dividing by 3, so this one's going to be 1/3. Right? 1/3 of 1/3 is 1/9. 1/3 of 1/9, or 1/9 divided by 3 is 1/27. And then 1/3 of 1/27 is 1/81. Right, you can see the same pattern holds. Right, 3 to the 4th power is 81. 3 to the negative 4th power is 1/81, or 1/3 to the 4th. All right, again, you can make the exponent positive, drop it to the denominator. right? Numerator of 1. All right, let's go back to this real quick. Let's say our base was 4, and we're just going to look at these two right here. Well, then 4 to the first power would be 4. The pattern, if you have base numbers of 4, would be multiplying by 4 each time you go up and dividing by 4 as you go down. So you're always multiplying or dividing by whatever the base number is. So in this case then, to get to 3 to the 0, you'd be doing 3 divided by 3. So we could look at it like this. If we were doing this in like an algebraic sense, we could think of, let's say, in fact, let me come down here and use this notation. A would be our base, so a to the first would be a. But then to get down to this one, since it's a that we keep multiplying by, basically to get this one, it would be a divided by a. It's always going to be 1, because you're always going to be dividing the base by the base to get to whatever the base number is to the 0 power. So anything to the 0 power is always going to be 1. All right, back to negative exponents though. So this is actually the rule. I don't really like us to think about rules and math, but if you think about this, this makes sense. A is the base number, all right? So a to the negative n is just going to be the same as 1 over a to the n. Nope, just change the exponent to a positive, drop it to the denominator, numerator of 1. This is always going to be true. Okay, so let's use that in a few examples here, right? And these are examples very similar to the ones that you had in the CPM book. I'm going to do my fractions with a slash line. It's not the greatest, but it's just quicker. And since I'm trying to do this on a video, I'm going to do it that way. So if you use that pattern, then x to the negative 8 is going to be the same as, okay, we're going to drop it to the denominator. We're going to make it positive. That's the same as 1 over x to the 8th. Like, oh, okay, right. Make the base positive, keep the base the same, right? Make the exponent positive, drop it to the denominator. We have now written this with no negative exponents. All right, well, what if you have one variable that has a positive exponent and another variable that has a negative exponent? Well, the only one we need to change then, in this case, is the y to the negative 7. All right, so we're just going to keep the x to the 5th the same. Right, but then we're going to put the y to the negative 7 in the denominator, right? And now we can change it to a positive. We don't need to have 1 in this case because the 1 is implied. So you could think about it as 1 times x to the 5th over y to the 7th. There are times we might need to have the 1, but in this case we don't. What about this one, number 3? All right, it looks like we need to do some multiplying first. So quick reminder. When you're multiplying with exponents, you add the exponents, right? But the numbers get multiplied like normal, right? So 5 times 4 is 20. In terms of my x's, since I'm adding them, this is going to be x to the 7th because I have x to the negative 3rd times x to the 4th, so x to the negative 7th. Y's, I have y to the 9th times y to the 7th, so that ends up being y squared, or y to the 2nd power. Right, but oops, we've got a negative exponent. Right, that's the only one that needs to be dropped to the denominator. This time I'm actually going to put parentheses around everything that is in the numerator because it gets a little bit confusing and sometimes it's not sure what, it's not always clear what we should be keeping together. But in this case, I'm going to put the 20y squared all together in parentheses. That tells you that that should not be separated. It would be easy to think that it's just the y squared as part of the fraction if we didn't do that, so that's another reason to do it. All right, then in the denominator, we're just putting x to the 7th. Oops, didn't do that right. All right, so there we have it, 20y squared over x to the 7th. There we have the answer, no negative exponents. Negative exponents are fine, but sometimes for certain subjects, especially chemistry, it isn't good to have negative exponents. It's good to keep your anything with negative exponents in the denominator. It makes it easier to do calculations. So that's partly why the CPM is asking that of you. All right, if you're looking at this one, 4x squared y cubed z to the negative 3rd power all cubed. This is taking a power to a power in terms of the exponents, but I just want to run through this one with you real quick. In terms of the numbers, you just do that like normal. So 4 to the third power is going to be 4 times 4 times 4. So that's the same as 16 times 4. So that's 64, right? And then it's going to be x to the 6th power, because 2 times 3 is 6, y to the 9th power, right? And then for the z, it's going to be z to the negative 9th power, because it's negative 3 times 3, right? In this case, and the only one that's negative is the z. So I'm going to just copy the first part here. I'm going to put this in parentheses, right? And that way it's clear that that should be all in the numerator. And then for the denominator, I'm just going to change it to positive 9. All I had to do was drop it to the denominator. All right, let's make this just a little bit larger. Right? So this one was actually a problem that showed up in problem 6-7 that you did not too long ago, and some people had some problems with this one. So let's go through it. All right, so this is negative 2x to the negative third power. Think about this the same way you would number 4, and that is you're going to do like we did 4 to the third power. You'll start with negative 2 to the negative third power. Well, negative 2 to the negative third power is really the same as, remember, it's like 1 over negative 2 to the positive 3 power. So I did the same thing here. I just dropped that whole thing to the denominator and then changed the exponent to a positive, right? And then we would multiply that then by x to the negative third power. But you know what? I'm going to change that right now too. All right, this would be the same as 1 over x to the third power. Might as well get them both into a situation where it's positive exponents right away. So I've changed both of them, the constant and the variable, so that they have positive exponents. Then you can think about it as numerator times numerator over denominator times denominator. Well, 1 times 1 is 1, so that's my numerator. I'm going to figure out right now what negative 2 to the third power is. Negative 2 to the third power is negative 2 times negative 2, which is 4. And 4 times negative 2, that's going to be negative 8. So negative 8, right? And then, so it's basically think about it, you could think about it as negative 1/8. Right? So I think I might change it to negative 1/8 in just a sec. Times 1 over x to the third power. So I'm going to do this again. And I'm just going to change my final answer to negative 1/8 times x to the negative third power. So I'm just going to change this to negative 1 over 8 x to the third power. All right, so I can see where some of you might be, wait, huh? Why did you do this? Okay, so this is negative 1/8. It doesn't really matter where the negative is. I think it's a little more clear to have the negative in the numerator, so that's the only reason I did that. So basically I switched my negative here, and then I'm just left in the denominator with 8x to the third power. All right, hopefully that makes sense to you. It's a little bit confusing to do this on Google Docs, so I might do one at some other point when I'm actually using pen and paper and writing as I'm going along. It might be a little bit better. All right, so what I'd like you to do now, though, is I have posted onto Google Classroom quizzes that I'd like you to try. First of all, you're going to have to accept my invitation to quizzes. I think it will let you in with no problem because you'll already be signed into your school Google account. All right, but give that a shot. So accept my invitation first. And then depending on whether you're on your phone or whether you're on your laptop, use this one. I'm going to use the quizzes web link. Okay, now I've already done this one, so this might look a little bit different to me. I have a few different accounts. I'm going to use my school account. Please use your school account. And it allows me to do several different things here. So I've already taken this, so when I bring this up, I'm going to make it start over. I'm going to replay the game. Yes, says Ellen Bailey. Okay, no problem. All right, and what happens is these questions come up. You have multiple choice answers here. Just choose the correct